Assalamualaikum. Our group would like to present about free body diagram, MIG robot arm. I would like to introduce our team member, Abdullah Afnan bin Shahri, Adam Ilham bin Azmi, Muhammad Akmal Farhan bin Mazuki, Nur Azlim binti Suhaini. What is center of gravity? The center of gravity or center of mass is the point where the whole mass of the body is concentrated. The point where the gravitational force, the weight of the body, the center of gravity of any object can be calculated by summing the weight of the body and dividing it by its origin. Like in the picture below, that we are deciding the center point in MIG robot arm. Okay, what is centroid? The point of the geometric center of the object. The density is fully distributed over the body. The point where the cutout is balanced perfectly is the center of the object. Structural analysis. A structure is a system of interconnected members used to support external load. Structural analysis establishes the relationship between a structural member's expected external load and the structure corresponding developed internal stresses and displacements that occur with the members when it surveys. Okay, in this structural analysis, the MIG robot arm is in the 3D. Then we change the structure to the 2D drawing to make it easier in the calculating. Our objective are to know the center of the gravity of the MIG robot arm. Second one, to know the centroid of structure. The third one, to know the direction of force, moment at the base support. And the last one, to sketch down the free body diagram of the structure. The process flow. The first one, we're measuring and obtaining crucial data on the given machine, such as weight, length, and all necessary data. The one, drawing the free body diagram by depending on MIG robot arm structure. The third one, developing the equation of equilibrium in Cartesian vector. The last one, analyzing and discussing the overall force acting on the MIG robot arm. I would like to pass to the next presenter.
Assalamualaikum and good evening. Okay, my name is Abdullah Afnan bin Sharin, metric number B0921101887, and I will be presenting about the calculations. So, from the slide that I've shown you here, the robotic arm is divided into three main components, three main parts. So, we can see here, number one, number two, and number three. Here we can see the FBD for each individual part. So here part 1 we have By, the forces is acting downwards, Bx outward. Meanwhile on the second member, By the force is acting upwards, Bx is inward. Meanwhile Cy is outwards and Cy upwards, Cx outwards. And for the base, for part 3, Cy upwards, Cx down outward also. Meanwhile, dx inward and dy is inward. Okay. For the next slide, here we will be starting our calculations. So, the question asks us to calculate the forces acting on each member for our part and on each joint of the part. So, for the first step that we are going to find is the center of gravity for the whole machine. So, as you can see here, we have created a table which consists of x bar, y bar, a x bar, a y bar. Here, this x bar is the middle point for the x-axis on part 1. This part 1, part 2, part 3. Y bar is the middle point for the y-axis. A is area, AX is the area multiplied by the midpoint for X bar. Meanwhile, AY is the area for the Y middle point for the Y bar. So, uh, f- in order to find the center of gravity for the machine, we have to take in account three main parts, all the summation of three parts, so that we can find the midpoint for the whole robotic machine. So for the first step that we have to find is the total summation of area for all the part, summation area multiplied by x bar, and summation area multiplied with y bar. So we get for the summation area is 0.6773 meter. Keep in mind all of this is in meter. Summation A x bar is 0.2566 meter, and AY bar is 0.1363 meter. So from there, we can substitute it into the formula, which is the summation for summation A x bar divided by the summation of area. So 0.2566 is divided by 0.6773 meter. We get the midpoint from the x-axis is 0.3789 meter. And for the y, we get 0.2012 meter. Okay. So after we calculated after we found the middle point of the whole machine, next step is to find the volume, which from here you can see is by using the resultant formula. So uh, we use the same concept, but we substitute it with the area from the x-axis and y-axis. Here you can see r is equal to square root some area of x bar square and ay square. So we have to do this three times so that we get the volume for each main component. So for part 1, we get 0.1454 meter cubic. Part 2, we receive 0.0318 meter cubic. Part 3, we get 0.1297 cubic. Okay, for the next slide, here we go on towards the next equation that we need to do, that is finding the weight and the mass for each part member before we start calculating the forces reacted on each joint. So from here, the given information that we receive is the total mass of the machine, and that is 225 kilogram, and not the total, not the individual mass for each part. So based from the formula weight equals to mass times gravity, we cannot use this formula because the mass that we have is the total and not the each member. We have now is we are finding the mass and the weight for each part member, not total. So we use the other alternative, that is by using the density formula, whereas density is equals to mass uh, divided by the volume. So as I said before, we have the total mass, and we also have we have each individual volume. So from there we can find the density of the material. So by using this formula, mass divided by volume, so 225 kilogram is divided by the summation of the volume that we calculated just now, we receive 733.14 kilogram meter cube, and this is the density of the material. So from there we can start calculating the mass and the weight for each individual each individual part, sorry. So by using the same formula, the density formula, we adjust the formula so that the mass is the topic. So mass is equals to density times by volume. So the density that we calculated just now is 733.14 is divided by the volume for each part. Okay. For part 1 is 0.1454. So we receive it. The mass for the part 1 on the top is 106.60 kilograms. And for the mass, for the weight, we times it by the gravity 9.81. We receive 1045.75 Newton. And for part 2, we receive the mass of the beam is 23.31 kilograms, and the weight is 228.67 Newton. And lastly, for part 2, the mass is 95.09 kilogram, and for the weight is 932.84 Newton. Okay, so that's all from me. I will pass this presentation to my fellow groupmate. Sekian, Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Farhan bin Tuha Marzuki, and I come from BMA 1. Now I will present the FBD and some calculation uh, for each part lah. And we have three parts that we have to calculate. For first part, we have fx. For total fx is we know fx for exists for x axis is bx, negative bx. For fy, by minus weight. We know weight is 1045 and 0.75. So we minus, so we get by negative 1045 and 75 Newton. After that, we can get the moment of B, weight, and the formula is weight times 0.55, which 0.55 is come from the length is 1.1 meter, and we divide by 2. So we get the moment of B is 575.163 Newton meter. Now we go to part 2. For part 2, for fx, we know that bx, negative bx, plus cx. Yeah, because they are go to same direction. So 0 plus cx, and we get the cx is 0 Newton. And for fy, by plus cy. By plus cy, because we are some same direction. And weight is downside, so we minus. So we get the cy 817.8 Newton. And we can get the MC, moment of C, bx times 0.6, and we get 0 Newton meter for moment of moment of C. Now we go to part 3. Part 3 is the downside lah. For fx, we know the negative dx plus cx, and we get dx for and the force for x, dx is 0 Newton. For fy, total fy, dy plus cy, same direction, minus weight downside direction, so we minus. So dy weight minus cy, we get dy 115.76 Newton. And we go to the moment of D, we can get the moment of D, cx times 0.475. This is the length for this. And we get a moment of D is 0 Newton meter. That's all from me. Thank you.
Habis keparut siang. Macam mana ni? Aku nak save ni. Selama masa semua kasih. Sikit perut dan pantai. Dah record kan?
Hi, my name is Adam Ilham bin Nazmi, and I will continue the last part, which is the conclusion. As the conclusion, we know how to find the center of the gravity of the MIG robot arm by applying structure analysis on the machine. We divided the machine into 3 parts and analysis it into 2D forms. Then, as we already obtained the center of gravity of each part, we also able to determine the centroid of the whole machine. Next, we apply free body diagram on each part divided. From here, we are able to find the reaction force and moment on each part. The free body diagram assume there are pin joints happen on the part. That's all from us. Thank you.